Hello
Okay.
and welcome to session 298 in the AISafety.com reading group. Tonight, Lau Mein will be discussing his article, Power Plants May Be a Bottleneck for AI Development. Please go
All
ahead,
right.
Lau Mein.
So I started doing this research because I kept hearing people talk about how electricity was um, a major obstacle in getting new AI trained data centers up and running. And initially, that sounded pretty implausible to me. But then I started doing some math and started doing some more research. And my conclusion is it is a pretty reasonable concern. And it may be a bottleneck that stalls AI development for potentially 2 to 3 years. So what's the current status of power use in the world today? Well, the world's electricity production is 10,000 gigawatts. That shouldn't be per year. That should just be 10,000 gigawatts. Um, and U.S. electricity production in 2023 was around 1,000 gigawatts, and it's been there for roughly the last 10 years. Um, in 2023, data centers in the United States used 21 gigawatts total. And McKinsey, when they did their estimates in 2023, expected there to be 30 gigawatts of data centers in 2030, but this year they revised it to 50 gigawatts. The only thing that's really changed has been the increase in the rate of AI chip production. It went from around 500,000 H100s. That's actually kind of weird because I've seen various different numbers, but 5,000 is roughly correct in 2023. And that's rising to 3 million in 2024. And yeah, the thing is, each H100 uses somewhere between 1 to 2 kilowatts of electricity, assuming you run it flat out, which you really should, given how expensive a card it is. So 500,000 H100s would imply something like half a gigawatt of electricity capacity, and that's just for 2023. And because of this, if we use McKinsey's 2024 estimates, that would require the United States to increase electricity production by zero point 0.4 a year. Okay, so here's some charts from some NGO, and it talks about world increases in data centers. And even with, and yeah, this is using terawatt hours, but the dedicated AI centers is roughly 30 gigawatts. Um, so yeah, it's relatively similar numbers. And as you can see, there is an anticipated large increase in data center electricity use, but most of it is not expected to be driven by AI. Anyways, so yeah, based on McKinsey's estimates, um, it's yeah, you would need to build up capacity, U.S. grid capacity by 4 gigawatts a year. Now, can you guys see the smaller charts like below? Can you see that?
I can see it, yeah.
Okay. So if you note the corporations, I think every single one is based either in China or the United States. I think CloudWeave and Lambda Labs are cloud service providers, so it's less clear where they're like. I think they have data centers all over the world, but the major players, the people who are really interested in buying um, H100 GPUs in 2023, were China and the United States. China is currently not allowed to buy H100s or even the downgraded like H800s that NVIDIA was trying to sell to China. So what does this imply? Well, what does this imply? Well, I think the future of AI data centers is going to be almost entirely in the United States. Uh, so let's do some of the back of the envelope math. Training GPT-4 took 25,000 A100s 100 days. Now, if we assume that Microsoft has 200,000 H100s, which they definitely do, given that they already bought like 150,000 by the end of 2023. If they run that for 1 year, they would be able to get something like 60 times the compute as they did to train GPT-4, which makes me expect GPT-4. Sorry, yeah, which makes me expect GPT-5 at the end of the year. So yeah, inference costs would also go up, but it's not lethal. And that's the price they charge. The actual inference cost for OpenAI, I think it's a lot lower. So yeah, I've heard people talk about building data centers in the Middle East, particularly in places like Israel and Saudi Arabia. I'm not so sure about that. It's The electricity isn't much cheaper there, and I have read articles about how there's going to be a $6 billion Amazon data center in Saudi Arabia. Well, there's going to be like a $60 billion or like $300 billion, something crazy like that being built in Northern Virginia. So like in terms of relative investment, the Middle East just doesn't have a lot of upsides. It's not what the talent is. It's not what the cheap electricity is. There's potential sanction risks. Apparently, U.S. has restricted H100 sales to the Middle East. Also, there's war and terrorism risk. But yeah, it's just I don't think there's going to be a 1 million H100 data center in either Israel or Saudi Arabia, because it's just they will need to build up their electrical grid considerably, and there's just not a lot of reason to do it there. So now let's talk about what we need in order to provide that energy. You can't use renewables because you want to run these chips, these cars, which are really expensive, essentially as often as you can. I actually had an estimate here where if you assume 10% depreciation for your H100s, that means electricity costs have to be really, really high in order for you to consider not running them, to consider turning them off. So as long as you can get electricity below 25 cents per kilowatt hour, which is, you can get that basically anywhere in the world, um, you'll be running them 24/7, which means that you need steady electricity production from either nuclear or like coal or natural gas. Given how expensive it is to build and how long it takes to build coal and nuclear, it's probably going to be natural gas. Let's see. Yeah, because natural gas can be built relatively quickly. They're quick to approve. Natural gas is really cheap in the United States. And yeah, there's also the thing with decommissioning coal power plants because a lot of the past couple of years in U.S. electricity production has been coal power plants being taken offline and replaced with natural gas plants because natural gas plants are cheaper because of fracking and cheap natural gas. So right now in Northern Virginia, a lot of coal power plants that were expected to be decommissioned are continued to be operated because it's easier to like run them more expensively than it is to like have a shortfall in electricity production. Um, takes a lot less time to not decommission a power plant than it is to make a new one. So yeah, um, like I said, U.S. Total electricity production is like 1,000 gigawatts. The U.S. has built like 40 gigawatts of natural gas electrical generation capacity per year in the past. It hasn't recently, but it's certainly possible. So yeah. Speaking of Northern Virginia, did you know that there's 2.5 gigawatts of data center capacity in Northern Virginia right now? It's like way more than anywhere else in the world. People talk about Texas and Silicon Valley, but Northern Virginia is the data center of the world. Currently, there is an additional 1.34 gigawatts of data centers being constructed in Northern Virginia. The vast majority of current production is being used for cloud services. So yeah, if you look at that graph, I think that's extrapolating off. I'm not sure how much of AI data centers that takes into account, but they seem to be able to build like maybe half to 1 gigawatt of electrical capacity per year, um, at the very least. If there's a huge surge in demand, I'm sure they can do more. So that is so yeah. It's like if a 1 million H100 data center needs to be built somewhere in the United States, you could probably do it within a few years in Northern Virginia. So what is my conclusion? Most AI data centers will be constructed in the United States. There's a lot of current scrambling because current electrical capacity is being bid up really highly. A lot of cities known for data centers are restricting their construction because they need to build the electrical capacity to power those data centers. So like, what if we get, say, 5 million H100s being put online in the United States every year? That's 10 gigawatts a year. Um, I don't think it's a huge problem. It's definitely doable. The United States has built that much capacity in the past, but if there's a huge surge, like if we get like 10, 20 million H100 equivalents being put online in the United States per year, we might see like a gap of 2 to 3 years while all of those natural gas power plants are being put online. And these are my predictions. I think there is some potential in like using NIMBY tactics to delay power plant construction, but like the places where data centers are being built right now are likely specifically places where doing that is very hard. But who knows? So yeah, that was my relatively quick presentation. Thank you.
Great. Thank you, Lami. Um, so, I have a number of questions, but the first one is, if we imagine that the timelines get pushed out a couple of more years in relatively public. I imagine this is something that, like right now, a lot of people care about AI, but a lot of people also don't care about AI. But if we are doing something like this, then probably that's going to get a huge amount of attention from people. Well, how do you see this play out with regards to like if everybody starts to talk about saying, "Oh, my power bill is so high because all these AIs are taking up all the power"?
I don't think that's going to happen. I think what's going to happen is I mean, what kind of what are you seeing? Are you thinking that they would be onlining these in like places where they would bid up electricity prices against consumers?
Yeah, I think this is an interesting question. What are your predictions about the price of electricity in 2027?
I don't think they'll be much higher than they are now in the United States because 2027, that's enough time for all of that capacity to be built up. And also, and also it takes like months, maybe a year or so for data centers themselves to be built and all like the infrastructure to connect them to everything. So it's like, I don't expect this to be a negative impact on consumers. And also like if AI can actually bid electricity up that high as a use, what's more likely going to happen is that the cloud providers in the United States, because I showed you there's like 2.5 gigawatts of data centers in Northern Virginia right now. The cloud providers are going to get squeezed out to different countries, and they're going to get replaced with AI training data centers, and that's like a huge amount of capacity. So I just don't see it being a huge deal.
Okay. The next question, the rest of you, if you have any questions, please, there's this raise your hand thing you can do with that I'm doing right now. Please use that functionality. Otherwise, I'll just keep asking questions, basically. So, Scott Alexander has some predictions. I don't know if you've seen Scott Alexander's predictions. Otherwise, I think I can just straight up share the link. Hold on.
Okay.
I will share his prediction in just a moment, and I where he tries to put some actual numbers on, or maybe I can just share my screen. That might be easier.
Okay.
Hold on, you can see my screen now. You should be able to see my screen in just a moment. So this is Scott Alexander's reaction to Sam Altman's statement that he would like 7 trillion for this. And he estimates that, well, GPT-4 took 50 gigawatts of power, of energy, gigawatt hours, and GPT-5 will have 1,500, GPT-6 45,000, and GPT-7 1.3 million, which is like, that is one way of making these kind of trends. How do you feel about these numbers? Do you think that we're going to see something like a factor 30 every 2 years or something like that?
A factor of 30 every 2 years?
Every generation, basically.
Every generation.
So
I mean, but that's like definitions, right? It's only a new generation if you need, if it's like a new big training run, it's only a new big training run if you like actually scale it up a lot. Otherwise, you're just wasting your time. So it's like, I guess, but I'm not less certain about like how spread out it is over time.
Okay, so here is Scott Alexander's attempt at actually drawing this, where in 2027 we will have GPT-6 that requires like a big power plant. We will get GPT-7, which is like the biggest power plant that has ever been created in 2031, etc. Do you think this kind of scaling is reasonable, possible, likely?
Well, it's definitely possible with GPT-5. You just need like a couple 100,000 H100s, which already exist. With GPT-6, I mean, man, now you're talking about like 3 million H100s, which given how fast they're cranking them out, I do expect that in like 3 to 4 years, someone will have like a really large number, like we'll have millions of H100s operating for, well, H100 equivalents operating on a single training run. Sure, I can believe GPT-6 estimates. I mean, when he says a city-sized data center, we already have those in Northern Virginia, so it's not a huge problem. So it's like, yeah, I think the scaling holds until like GPT-6. If you genuinely wanted 30x GPT-6, like we would be talking about man, like 100 million H100 equivalents. So like
Scott Alexander says, I haven't double checked his, he says the largest power plant in the world is the Three Gorges Dam in China, and it would require 15 of those to train GPT-7, which seems like something that you probably will not have ready by 2031.
Yeah, that's like what, 20-30% of US electrical capacity. If you distribute it across the world, certainly. If you really, really, really need to build it in the United States by 2031, it's actually not that difficult because we're talking about like 300 gigawatts. The US has online like 40 gigawatts of electrical capacity in the past. So that's like what, 7 years, 7 times like 40 is 280. It's not crazy. It's doable. But like it's on the limits. It's very much on the limits of what's reasonably possible in the United States.
Okay. There are some other these kind of naive extrapolations. I found another one that I guess I should probably send it to you so you can read it, not just from myself. Let me just see if I can get that to you. How can I get to the chat without? So it's a bit annoying. I can't access the chat here and here. And let me just paste in the link. Why can I not go to the normal link? Hold on. Create chat here. So that's a bit annoying. I can't paste this in here. Let's see. I may have been able. Okay, then I'll have to show it. So this is from a less strong user who made an analysis trying to put this into some more. So here is like the way he's doing this trending. You can see GPT 1, 2, 3, 4, and then for GPT 5 he has both bullish and more mainline predictions. And so you can see the flops, parameters, GPU models, and I think we will probably talk mostly about the energy consumptions, how that goes up here. So here is the like I am not 100% sure I understand all of this, but it looks like we are going to see already very soon here for this column is I think this column is GPT-4. This is GPT-4. So GPT-5 already when we get to GPT-5 we will start seeing something like 8 times as much as oh, now I'm starting to get in doubt about this. This can't be right. Now I'm getting in doubt about what this actually shows. I think I don't actually have the question that I thought I had about this. Did you manage to get the link here that I sent?
It's it's showing up as a PNG of the link.
That is reasonably annoying. How can yeah, I wanted now is perhaps not something that we should talk too much about unless you can very quickly get something. Otherwise, I have some other questions, and most of the other questions I have to do with AI safety, because
okay. Yeah, go ahead. Other questions.
My intuition is that this is something that is potentially quite relevant to AI safety, in that if people decide that they want to make an AI pause or something like that, then these kind of power requirements ought to make it really, really easy to see whether a pause is happening, right?
Yeah, it's not just, oh, you need to build a really big power plant. It's like you also need to build the really big data centers. It's a huge amount of infrastructure and a huge amount of like human infrastructure. It's impossible to keep secret, I think.
To what extent is it possible to keep safe from, let's say, the United States wants to do this in Virginia, and they build a city-sized data center, and they build something like would. Yeah, I'm trying to figure out what would terrorists be able to stop something like that? Do you think?
Would terrorists be able to simultaneously put offline like 100 or like 10 or 100 gigawatts of electrical capacity distributed across hundreds of plants long enough to make a difference? I don't think so.
Yeah, I think in general I would agree with you. The reason why I think this might be slightly more plausible is from the fact that this might need to be exceedingly centralized, right? The more centralized, the better. And once you're starting to thinking about like extremely compressed architectures, then it may be more vulnerable.
I mean, it's like, what I'm not really sure what we're talking about. Like, if we're talking about like radiological, like Chernobyl levels, maybe, but like no one's really been able to pull that off. Like no one's really been able to pull off an intentional large-scale poisoning incident that successfully killed people, like more than a few people, which is crazy. So it's like, I think terrorism is really hard, and the people motivated enough and capable enough of committing terrorism can do things in real life, and they don't feel the need to commit terrorism.
I think that is almost certainly true for all other things than this subject. which is why I asked that question. Okay, so another issue is, let's say that we end up in a situation where like airstrikes become relevant. Let's say the United States doesn't want to build this, and they agree with China that they don't want to build this, and later Iran wants to build something like this. Can that be done in a way that is safe from airstrikes, do you think?
I mean, Iran,
Yeah,
Iran can't pull
Iran.
it. I think Iran can't pull it off because like there are I vaguely recall various proposals about like bunker busting munitions in Iranian nuclear facilities, and the conclusion is just that like they can't really defend their nuclear facilities against a dedicated Israeli or U.S. attack. So Iran, no. If your opponent has nuclear weapons, though, like
Mm-hmm.
China or Russia, really the only people who can pull off the whole AI thing is China and the United States. So it's like we're really talking about two actors here, and
Mm-hmm.
I China is intelligent enough
Mm-hmm.
to make to set up these data centers such that striking them would equal immediate nuclear escalation. Like you could put them
Mm-hmm.
inside the Three Georges Dam, in which case they get the power, and also if you like hit them hard enough to destroy them, you also kill a couple million people through flooding. So that necessitates nuclear retaliation. Therefore, striking the data center equals like just nuking a Chinese city. It's like it's the same thing. So yeah.
Hmm. Yeah, and like I think we're probably getting a bit off topic here, but I actually think the game theory might work out somewhat differently. But I think we should perhaps stick a bit to closer to the subject. Um, so let's. Do you think one? There are obviously two ways that all of this can be invalidated. One is that we find um, a new paradigm that is less power hungry. That seems like a thing that could happen. And also we somehow get become unable to make the expected power improvements. Um, what do you think about these two? Let's start
What do
with
you mean expected power improvements?
I think the models that we are working with assume some level of algorithmic improvements, right?
Uh, I mean, what algorithmic improvement was there from GPT-2 to 3 to 4?
I think there were actually quite a few. I
Yeah,
remember
I mean,
seeing.
yeah, but like it's still the same architecture. It's not huge.
Yeah, I think I saw some numbers saying that the if you want to train something like GPT-2 with current architectures, you could do it dramatically easier and cheaper with much less compute and much less power. Am I off base here? To what extent
I
is yeah?
I think maybe it's like training methods, like how much data versus how big a model, something like that. I'm not 100%.
I really ought to have looked up some numbers. I believe I saw some numbers saying that, in fact, the power consumptions required for this kind of training has dropped dramatically, and I thought this was kind of implied with these models. So that was what I was looking for the
Maybe
counterfactual.
that's like because when they trained GPT-2, they didn't have like A100s, I don't think. I mean, that was a
Mm-hmm.
huge improvement. So there's that.
Yeah. So if we assume somehow that the models that we're currently using are wrong in the sense that all of this requires dramatically more power, what would happen then? If
I
suddenly,
mean,
yeah.
like when you're training a model, the inputs are the hugely expensive um, AI cards and electricity, and most of the cost is in the AI cards. Like, and it's also an upfront investment. So it's not the big obstacle in getting like a 10 million H100 data center isn't like the what 10, 20 gigawatts of electricity it would take. It's like the 400, $300 billion it would take for the cards alone. And then you build the infrastructure. It's like, yeah, like building like 10, 20 gigawatts of electricity is easy. Getting $500 billion to invest in AI is hard.
Okay. That does make sense, yeah. So let's try to go the other way. What happens if we get a more decentralized paradigm? Something that allows maybe some kind of distillation technique that allows uh, a much more decentralized training that we are thinking. In that case, obviously, a country like France could make sense again because they have nuclear power that seemed like it could be scaled up dramatically. Do you think something
Uh,
decentralized like that could
not
happen?
not not fast. Like you can't scale up nuclear power fast. You need years and years. You need like a decade, at least 5 years, in order to like get through the approval process, all of that stuff. So it's like, um, Bill. So yeah, nuclear power just isn't a major consideration in all of this. They have been like buying up data centers from like cloud providers that are located right next to nuclear power plants. Nuclear power plants, you have a lot of upsides because they're extraordinarily consistent. Um,
Mhm.
so there's that. But in terms of nuclear power plants, no way in hell.
Interesting. Okay. So my model of a like if there was some improvement that allowed extremely decentralized training to happen was basically that there would be uh, uh, data centers located in all electricity markets, such that it would the price would basically be driven up by this, and it would be much more of like a free market structure. Do you think this is a reasonable thing to expect? If it's completely decentralized, so you can basically train part of it in Denmark, and then when there
I
is
mean,
low energy price.
you should look at cloud provider services
Mm-hmm.
because those are essentially completely decentralized. And
Yeah.
yeah, they go to places with low regulations, low taxes, and cheap power, like Denmark, Sweden, Ireland, um, plenty of places in the United States. But like overall, um, man, it's like I think there's still a lot of stuff regarding human capital and like um, programmers and like being physically having the people writing the code being physically closer to the data centers might still be a good idea overall. And it's like there's efficiencies of scale, like there's various regulatory stuff. I would still expect there to be a lot of concentration in like existing mega data center markets like Northern Virginia.
Interesting. Yeah. Okay. Um, Again, if someone have questions, I don't think I can actually see if you're raising your hand right now. So another question that I am struggling with in this is training versus inference, because obviously people are not going to build GPT-7 unless they get a lot out of GPT-6, right? We would imagine that if we push something like 20% of the United States energy generation towards training GPT-7, it's probably because we are running GPT-6 like a lot, right? Um, how do you see this happening? Do you think that inference costs will end up dominating training costs, or the reverse? Or like my intuition, I've written here that the intuition is that they're growing in lockstep somewhat. So the amount of compute we use for training and the amount of compute we use for inference are growing at the same pace. I don't actually know if that's true. What are your thoughts on these two questions?
Oh man, I'm like completely spitballing here, but I think like a single inference is like roughly the same cost as a single back propagation. So it's like because you need because as the amount of training compute goes up, the number of backstep operations you need total to train a model also goes up. So like inference becomes relatively cheaper. I'm not sure. I'm not sure about this at all, but it sounds like it could be true.
Yeah, it feels like if we are assuming that ChatGPT right now, I don't know how much it costs to run. Probably, I don't know. But if suddenly it becomes like 100 times as large, or 2 generations out, it will be 30 times 30. That's 900 times as expensive. That seems like something that would dramatically change how we use ChatGPT if the price grew by 3 orders of magnitude.
Yeah, I think at that point you're like, each query would cost you like a few cents.
It's not more than that. If it increases by 3 orders of magnitude.
I mean, right now it's like $20 per million input tokens.
Yeah.
So like, crap. I actually completely forget the math on this, but it's like, um, if you're putting in like 10 tokens and you're getting a 20 token response, then that's 20 times like 20, it's like couple hundred, it's like 1,000. So like, if that also goes up, I don't know. I don't know the math on this. I'm sorry.
Okay, cool. Then here's a really kind of really simplified version. Like if we assume that the training energy costs and the inference energy costs increases at the same time, then maybe we should like just multiply the numbers that you have by 2, because we assume that we both need to build new power plants for training and new power plants for inference. So actually, all the numbers should be doubled.
Oh, well, I mean, inference can be more decentralized, but yes, sure. But like, well, if we're talking about like exponential stuff, if it's like, okay, right now I'm training GPT-5, but we're running inference on GPT-4, like you're always, if you keep doing that, you're always going to be spending a lot more on training than inference, because you're training the next model, you're running the current model.
That's true, but yeah, that's assuming that it takes that you're always training a new generation of models, and most of the time you're not training a new generation of models. Probably right now.
I mean, I'm pretty sure they're training GPT-5 right now.
Yeah, but there was a long time where they had GPT-4, but they were not training GPT-5.
Yeah.
Right. At least I think.
I
so.
think that was like limitations on like hardware.
Yeah, and maybe that will change to be limitations on power. So I think
Highly unlikely. Highly unlikely. I still think like power is not like the bottleneck. It could be a local bottleneck. Like if you're like, oh, well, I want to build a data center, and then you go to the city and they say no, we have like power centers booked up, and we're building the power plants, but it's going to take years. And then you're like, oh crap, let me go to the next market. But like eventually you're going to find a market. And if you can't find a market, you can like squeeze out cloud providers, and new power plants get built, stuff like that.
Okay. So a couple of sessions ago, we talked about the new California regulation SB 1047 that put a cap on that put some requirements on models based on like how much compute they were using. An alternative way would be to put a cap on models according to how much energy they were using. Of course, this should be roughly equivalent, right? As far as I can tell. But one thing that I think would be from a rhetorical point of view. I actually made a tweet on this. I don't know if you can see my tweet here, where I use this as an with the assumption that people probably feel much more like something that requires a lot of energy is important in a way that people can't relate really to floating point operations. Like it's for instance GPT-4 requires something on the same amount of energy as the bomb dropped on Hiroshima, and I think if you use this kind of language, then probably it does feel a bit emotional and maybe not perfectly rational, but it does have this kind of emotional appeal that the thing that these AI companies are doing is actually something that is really, really big in the real world. And I think maybe people will perhaps feel that if you make some kind of um, law that requires that all models should be regulated models about a certain size, people will feel this hurts small businesses. But if you say it's only if you use as much energy as a nuclear bomb, then people will feel that some kind of regulation is reasonable. How do you feel about this kind of argument? I don't like it very much
Uh,
myself.
yeah, I don't like it either. It doesn't seem very convincing.
Yeah, I think towards like lay people. If you say something that you need to have a permit if you want to do something that has enough the same amount of energy as a hydrogen bomb, then most people will say that sounds kind of reasonable, right?
Yeah, but then it's like, well, that's as much as say an aluminum smelting fact plant uses, and it's like, how much regulation do you really put on them?
You do in fact
Yeah,
put quite a bit
I
of
mean, you
regulations on
do,
people
but it's
who.
not like, but like
Mhm.
you put regulations on data centers already, so it's like, what is your ask?
Uh, that well, I guess the ask is some kind of safety regulations or some kind of insurance. I think if you want to build an aluminum smelting factory, then you probably need insurance, so that if
Hmm.
there's an accident and destroys the city you're in or something like that,
Hmm.
then the insurance covers. And most people will say that seems eminently reasonable. Um,
Hmm.
and then perhaps people will also say that for AI models, if you are like what this is showing more to me is that this is something where you actually need to have serious safety engineers in some sense, right? If you're building a aluminum smelting factory, you need to have some actual engineers who are experts in the safety of the system in a way that can document that this is following industry best practice and things like that.
Okay.
And that's the thing that SB 1047 is also asking from the model builders.
Okay.
And I'm sure, I'm
But then,
sure that mentioning Hiroshima and hydrogen bombs would have excellent rhetorical value for the environmentalists, because they've done similar things in the past. So even if it's
yeah,
not strictly rational,
mm,
it would have emotional effect.
yeah. Unfortunately, I also dislike it because I think this is a like I think this is a pretty bad argument that I'm making here. But I think it could be useful. So let me one other obvious cause of resistance to making a huge amount of fossil fuel plants would be from environmentalists and people who are worried about the climate. Do you think there will be any resistance from that front?
I mean, like Virginia built like 1 or 2 gigawatts of electrical capacity, or like deferred the shutdown of coal power plants over like the past 3 or 4 years. So no one's really like people on the ground. There's like maybe people who care, but overall, there's like been no uproar. I mean, I didn't even know like Northern Virginia has that much data centers until I did some research for this.
Yeah, I think this is also a thing that was surprising to me, but it feels like most likely if the AI companies are going to do something like this, then it will in fact be much more public, right? A lot more people are going to be aware of this compared to the data centers in Northern Virginia.
Is it though? Like if Northern Virginia like doubles their doubles their data center capacity every couple of years. And so is Austin, and then there's like a new one built in New Mexico and another one in Alabama or whatever. Um, like I think it barely makes the news.
Hmm. Well, um, interesting. Uh, Obviously, something like GPT-5 is going to have like to very much reach the news, right? I would expect.
I mean, in terms of like the infrastructure needed to like train it,
Mm-hmm.
not really. I mean, like we're talking about like 100 to we're talking about like basically a couple hundred kilowatts of sorry not kilowatts crap yeah uh meg couple so, yeah sorry megawatts, a couple hundred megawatts of electricity, and it's like that's so small in comparison to, multi-gigawatt data centers like Northern Virginia. It's just
Mm.
it's a drop in a bucket. You're gonna see like bigger stuff happen. Like, oh, we're doubling capacity in like a couple of years. We're building new data centers everywhere. Like what GPT-6, but GPT-5 is like it's being trained right now with existing infrastructure, so it's
Yeah.
not a big deal.
Yeah, I agree that this is probably not something that we're going to see right now. But for GPT-7, if we're talking about something like if it requires like 15 times the largest power plant in the world, then
Mhm.
almost certainly some environmentalists are going to take notice, right? And possibly quite a few. In particular, if it's not like the Three Gorges Dam is like uh, uh, not emitting any CO2, but if it's like built using natural gas, then I expect a lot of people will see the impact on the climate.
What do you mean? Like an extra couple hundred gigawatts? It's like, oh, humanity's electricity production goes up by 3%.
Hmm.
Okay.
Yeah,
It
I were like environmentalists in the United States have like stopped smaller projects to say the least, right?
yeah. It depends on the state. I mean, the reason Virginia is such a good place for stuff like this is because like they have fewer regulations. They're pretty friendly to massively scaling up their electricity infrastructure and like,
Mm-hmm.
uh, stamping all of the approvals really fast. So,
Mm-hmm.
I mean, like other than state and federal law, like what if the state is okay with it and the federal government thinks it's a strict like national security issue and it's hugely important, things generally get done.
So, like, I really don't have a good overview of the possible Democratic contenders if Biden does not choose to run. But I believe that some of them have been like a lot more interested in lowering CO2 emissions.
Mm.
Um, but and that is in fact something that would stop this or limit this to some extent, right? If I'm gonna say Kamala Harris without actually knowing that, but if she becomes the nominee and wins the next presidential election, in that case, that is something that could severely limit the ability to like build 3% more power plants, right? Or require that it should be
Uh,
solar power or something like that.
I mean, see now like we're going into territory I'm not super prepared on because I
Sad.
actually don't know what the cost of like solar plus battery is. If it's above like 20-30 cents per kilowatt hour, like in theory that
Mm.
might be a thing. This whole AI revolution might get squeezed to like China or Singapore or well probably not Singapore, but like maybe it might get squeezed to Europe. Who knows?
Mm-hmm. Yeah. Okay. Um, let's see. Do I have more? Yeah. Some of these tasks require a lot of engineers. Like obviously, if we are going to build something like GPT-6, we are going to need some electrical infrastructure at a scale that really hasn't been done as far as I can tell. And the people who are like experts in setting up this kind of system seems like a reasonable bottleneck. Like you can't make more like what are they called? This kind of electrical engineers that deal with power plants. Do you think that could be
Uh,
bottleneck?
No, the United States did install 40 gigawatts per year during like the early 2000s. That's like 4% of US electricity production. It actually hired them back then. So it's like, it's doable. They could build all the turbines, they could find all the engineers to like
Mm-hmm.
operate the power plant. So it doesn't seem like a huge problem.
Okay, neat. Um, yeah. So I think I don't actually have more thoughts that I want
Oh,
to.
Chris, you have a question?
Ah, wonderful.
You're muted.
Yes, yeah, sure. Yeah, I just want to go back to square one and have your very first graph. Could you just clarify something for me? Um, it's the one that's headed U.S. electricity generation by major energy source, 1950 to 2022, and that's in units of billion kilowatt hours. So
Yeah.
that's units of energy,
Hmm.
where I would have expected to see units of power,
Yeah.
yeah, units of power. So I'd have expected uh, I'm trying to interpret it as something like, number of terawatts of generating capacity installed or something like that. And then I don't say, and it's leveling, I see it's leveling off towards the end, but I don't understand billion kilowatt hours unless that's per year or something like that.
Yeah, yeah. It's when it's generally billion kilowatt hours per year, something like that.
So okay. So that's the amount of, is that the amount of energy that's been generated then per year for each year?
Yeah, let me pull that up. I'm sorry. Are we talking about my Listron post?
That's right. Yes.
Yeah,
The very
let me.
first.
Lau Ming, could you share your screen again, please?
Yeah, I'm pulling up the post. Okay. So
Yeah.
yeah, this one. Yeah, billion kilowatt hours. So a kilowatt hour, if you divide it by 3,600, you get like kilowatts.
Right. So, and that I can understand because you can express, the U.S. electricity installed generation capacity. You can express that as in terms of, I don't know, terawatts or something. But anyway, in terms of power,
I
what?
think a lot of it's because like a lot of sources are variable. Like renewables, they like um, sometimes you get them, sometimes you don't. I think some natural gas plants also shut down, stuff like that. I don't know why they do this.
Um, so the thing that's leveled off at the top,
Mhm.
the very top of the graph is horizontal. Uh, does that mean then that the amount of electricity generated by the US has stayed steady over those years?
Basically, yes.
Okay. I mean, so it looks like, so it does look like those are the wrong units as far as I can see. Because units of power, I can understand, but units of
I mean,
total
it's like total energy generated for the entire year.
per year. Okay, so all right, so it's per year. I got to
Mhm.
imagine
Yeah, yeah.
slash year put at the end. Okay, all right, and that I can understand. Yeah, yeah, and it's amazing that it's been horizontal for these last, I don't know, 20 years or something.
Yeah, yeah.
Um, and it's a big shame because the less energy you're using, the poorer you are.
Yeah, and note that how much coal has declined. A lot of those coal power plants are mothballed. They can be reactivated, and they're like getting replaced by natural gas. But if we see a huge uptrend in um, data centers, I think a lot of the coal power plants are going to stick around for a while natural gas continues to get built.
Uh-huh, yeah. So the big picture is the US has been marking time. I mean, obviously, I mean, the US economy has got a lot bigger in those last 20 years. Yeah, it's still powering ahead. While other countries like my country aren't doing so well. So they've been getting more GDP out of a steady rate of energy output.
Yeah, I think a lot of it's like manufacturing moving overseas, but yeah.
Oh, some of it's been exported
I mean,
overseas.
most electricity isn't commercial. It's industrial.
Yeah. Um, yeah, I'd still like to know where all the wealth is coming from. I mean, is it all gone into services or something, or rather than things that
Yeah, something like that.
Interesting, interesting. Thanks.
Okay, I have a new question.
Hmm.
So this is, of course, this kind of totally impossible question that, but just very roughly, imagine that for some reason, like we found a power plug with infinite amounts of energy or something like that. So we didn't have any problems getting new power plants. Um,
Hmm.
if that were the case, then we have this graph here with this particular slope here, with how long time it's going to take us to build all this. If power was not an issue, how much steeper would this slope be? How much is your estimate? How much faster would things progress without the challenge of building power plants?
Um,
I
I
know it's
think
an
there's
impossible
going to
question.
yeah, I think there's going depending on how fast um AI chip production gets scaled up. If AI chip production like continues to only be a couple million a year, H100 equivalents, then the difference is like there's going to be I would expect there to maybe be a couple months of slower growth as like, the capacity gets shuffled around and new power plants get built or whatever. But like overall, it's not going to be a very big effect. If it gets scaled up massively, like if I don't know, in 2028 we get 100 million H100s built a year, which is pretty crazy. If something crazy like that happens, then yeah, I would expect um, there to be a much bigger delay. And also, see, now we're talking about stuff like operating cost and like investment. If it's like if if AI training costs like maybe like electricity accounts for like 20-30% of all training costs. So like if that goes away, it becomes cheaper. So maybe people are more willing to scale it up. I don't know. That's the ultimate um, answer. I don't know.
Yeah, fair enough. Okay, great. So I don't have any other questions. Does anyone
But
else?
like overall though, like the effect isn't huge. Like it's still about economics, still about how many chips and how much they cost and like electricity is a small part of that. It can be a bottleneck insofar as like building a 1 gigawatt data center may be really hard or impossible in a few months. It may take you like a year or two because you need to find a location and you need to build out the power infrastructure or bid it out from other people. Like it takes time. That's what power does. It slows things down if you're trying to scale things up too quickly.
How do you see these two things? Like you have electrical engineers who build power plants, and you have computer scientists who make the algorithms more effective. How do you see
Yeah.
these two scale funch against each other? Is it like uh, uh, is like you could imagine that you, instead of spending the money on electricity, you hire some computer scientists to try to optimize the training in some sense. Um, and obviously, people are right now in some kind of equilibrium where they are both buying power from the grid, and they are also buying buying new power plants and also making improvements to the chips. But do you feel like it is like much more efficient to just buy a new build a new power plant compared to uh, getting more engineers to work on the optimization, the algorithmic side?
I
Um,
think
mhm.
they basically bought out the market of engineers who can really do that, is
Mm.
my impression.
That's actually a really interesting thing. Yeah, there might be like a very primitive model could say that you need an IQ of 160 to improve the algorithms, and in order to build a power plant, you don't need an IQ higher than 120. So that means that there's a lot more people you can hire to build power plants compared to improving the algorithms. Is that a reasonable model? Is of course,
Yeah.
yeah, interesting. Yeah.
And of course, we've not. The great unknown is what brilliant innovations AI itself will bring in that will enable us to generate and distribute energy much more cheaply.
Hmm.
The obvious
Yeah.
answer here would be fusion power, right? Um,
Well, fusion power and like superconductors,
uh,
because like superconductors seem like something that AI can crack. It seems it's this like weird nebulous thing that's like we're not really sure how it works, but it seems like an AI with better understanding and better intuition of physics than humans can just crack it and give us a cheap, room temperature superconductor. And once you get that, like, you know, you'll be able to conduct electricity from anywhere to anywhere else for super cheap.
mhm. And that would, of course, help somewhat, at least in the early stages, right? But once you start to uh, uh, like it wouldn't help us once we get to like GPT-7 levels, right? Because
Well,
then
I
we
mean, if you're then you can like have a global if you're really crazy, you can have like a global electrical network that shares power between renewable sources, and that might drive costs down. But really, I think that's really fanciful.
yeah, and I think like something like fusion power also seems like it's uh,
It
really
takes
gonna,
time to
yeah,
build.
yeah, that will, depending on if you're super intelligence, right? But then in that case, all of this is pretty moot.
Mhm.
The super intelligence that is using nanobots could probably do that
So
really fast.
yeah, so it's really weird that we haven't seen like pause AI people talk about using NIMBY tactics to slow down data center and power plant construction. I think that's kind of weird.
Do you think that would be an effective tactic?
Like, well, I think the people in Silicon Valley will want to build data centers in California where the tactics like this may be effective. I think they'll try it at first, and then if no one objects, like that might just happen. But if that doesn't work, they'll probably relocate it to Northern Virginia. Like, how much of a penalty are they taking in that case? I don't know.
Mm. Yeah, it's hard to tell how. You were also putting more weight on co-locating the engineers and the data centers. That was a bit surprising to me. Why is that important? Can you just have all the engineers in Berkeley, the computer scientists in Berkeley, and the power plants and data centers in Virginia?
Um, I don't know. That's more like personal experience. Sometimes you have to like go to the laboratory and yell at people and like figure out what's
Mm.
going wrong. And like it's just having the engineers who work at the data centers being able to like socialize with the people who write the code. It seems like it should be like cause an increase in efficiency somehow. Like it seems like a good idea, but I don't know. It's one of those things where it's like, well, let me put it this way. One of the great things about being in a city, in a particular part of a city right next to a bunch of other people who like work on roughly the same field as you do, is that like a lot of ideas get exchanged. So as you scale that up, it's like you can get some more interesting ideas and people can like jump from one career to another. And I don't know. It's just a gut intuition. I can't really explain it.
Fair enough. I share the same intuition that this kind of co-location is actually pretty important. Um, yeah, cool. Well,
So am I right in, unless you wanted either of you to provide a summary, I was just going to ask, so the summary is, the bottom line is that you don't, on any of your scenarios, I mean, you think any bottlenecks, any delays, we're talking just about a few years. Uh,
Yeah, yeah.
Nothing really significant in the grand scheme of things.
I think a few years is significant.
yeah. Uh,
Okay. Nick Bostrom would say, well, that represents untold quadrillions of lives in the future universe. But if we don't
Well,
if we don't take a long-termist view like that,
I mean, if you really, I think there's a scenario where, I mean, as part of my research, like I noticed that numbers and future estimates went all over the place and they're jumping around constantly. Like McKinsey's estimates went from, oh, data centers may use like 50% more energy in 2030 to, oh, they may use like 150% more energy. So it's like there's a huge amount of uncertainty. So if like the power plant people aren't sure that the whole AI bubble isn't the whole AI thing isn't a bubble. Maybe they're more reluctant, and then the AI people noticing that they're more reluctant, like there might be more reluctant to build new data centers because like electricity, like the expected future of electricity may be kind of like problematic. Like I can see the whole thing getting jammed up, but I think there's a lot of money in this, and people are going to try really hard to make sure it doesn't.
Yeah, I agree. To some extent, the bottleneck framing might not be providing the right intuition, right? That like I see the problems with building power plants as something that makes the slope of the increase less dramatic, but there's no like bottleneck effect that suddenly we get to a point where we just don't have enough electricity and then it just completely stalls out, right? So it's not really a bottleneck, it's just a defeat. In the same way that lack of training data is also something that's gonna limit the models, but not gonna stop the models. So lack of training data is also something that makes the slope of this graph more horizontal.
Yeah, something like that.
Yeah.
But then it's like, okay, if you have to build a power plant ahead of time, how much is that really costing you? It's yeah. If you just distill it down to a cent per hour of operations, it's like, is it really going to cost that much? I'm not so sure.
Mm.
I think it's still all about upfront investment, and like most of that's going to be in the chips and the cards.
Yeah, and also there's gonna be some kind of if you again imagine that you had a magical plug where you put in some money, like a reasonably cheap price, and then you get electricity out. If you had that magic thing, so you knew there would be no bottlenecks on.
I mean, that's called the U.S. economy.
Yeah, yeah. But okay. So the idea is that if it was a well-known fact that there would not be any kind of power bottlenecks, then Nvidia would produce more chips compared to the world, where we expect strong bottlenecks on the ability to actually power these cards, right? Because Nvidia will not produce as many cards if they don't expect there'll be buyers because the electricity prices will be too high.
Yeah, that's actually a pretty good idea because it's like like the limits of power plant scaling may mean that Nvidia like scales up their operations slower, so like they won't immediately like try to pump out 10 million H100s a year. But like I don't think that's a world we're in, because I don't think like OpenAI or Meta is going to be spending like $500 billion on Nvidia cards in the near future.
Actually, this is something that also a question that might be somewhat separate. My I can't go and buy an H100 card right now, right? There's a waiting list or something like that, right?
I mean, there's secondhand sellers. You can I'm pretty sure you can go on eBay and buy one.
Okay,
You can definitely buy an A100.
okay. Let's say I want to like buy something, like buy a lot of like I want to buy 20% of the of Nvidia's production. Can I go and buy that from Nvidia? I'm pretty sure I can't.
I think you get put on a waiting list or
Yeah, there's a
something.
waiting. Why is that a waiting
I
list?
think
Why don't they just increase the prices?
that's actually a really good question. I think it's so like market projections, like if like they put their prices to like 100,000, then people are going to price into the future. Whereas like if they stay steady and make it $30,000 like even while there's a shortage, then that's sending a really strong market signal that, yeah, in the future, like 2 years from now, it's only going to be $30,000. So then people are more willing to actually go out and like build 1 gigawatt power center, 1 gigawatt data centers.
Yeah. Yeah, that may be it. Hmm. Yeah, it may also be that Nvidia is unable to just scale up as much as they want. I don't.
Yeah.
It's
I mean, they're scaling up massively. They sold 500,000 last year. They're going to sell like 2 million. I've heard rumors they may go as high as 4 million this year.
Mhm.
The real big question is what happens in 2025.
Probably there will be some new generation, right? They won't be building
Oh yeah,
H100s forever.
there's already a new generation like announced. I think it's like Blackstone or something.
Blackstone. Probably we are gonna hear that a lot. That name, Blackstone. It sounds cool.
Blackwell, yeah, Blackwell. Never mind.
Blackwell.
Yeah.
Cool. Yeah. And probably like my intuition is that it will be more energy efficient.
I mean, I'm not really sure how much more energy efficient H100s are over A100s, but like the low-hanging fruit is already plucked. The low-hanging fruit of let's build specialized architecture for AI training. They got like 100x out of that, which is really, really strong. But once that fruit is plucked, like it's just hard engineering from there out. There's not going to be a massive increase like that again.
I would point to one obvious thing they could do, and that is to build it explicitly for GPT-6. Like, so
Oh,
it's not just an AI chip; it's a chip that is designed for a single purpose, and the only thing it can do is to train GPT-6. So it's perfectly optimized for an extremely, extremely specific case.
it's funny you should mention that because there are also rumors that like Microsoft and Facebook are doing exactly that.
So that might mean that there is like one more degree of specialization that's possible.
Yeah, yeah.
And we can imagine things that go further, right? Because the actual way that this training is done is like in several steps. Like it's there, like when you actually drill into how this training works, is I think I've heard it called like a 4D process or something like that, where there are like some cards do some of it, the process, and some cards do another. And so you could imagine an architecture that is specific not just to GPT-6, but to a specific part of the training process of GPT-6.
Yeah. So like just looking at this graph again, I just want to say my final conclusion is that like GPT-5 is in the oven right now. It's being trained with existing infrastructure. GPT-6 is we're well on the path to GPT-6. There like all the data centers are getting built. We really only need like a couple million H100s or equivalents thereof. GPT-7 would be like a monumental task, but like Nvidia's market cap was what, $2 trillion? Yeah, someone like, I don't think it's crazy that in a few years, people scrape together enough money to train GPT-7 if we get really good results. Like, I'm trying to figure out what that world would look like. And I really like your opinion on it because it's like, okay, so if we get GPT-5 and it's as good as GPT-4 is to GPT-3, and that encourages people to train GPT-6 and GPT-7. What would GPT-5, 6, and 7 even look like?
Yeah.
I'm trying really hard to think of it. And like, how does that not fundamentally transform human civilization?
Well, I have a short timeline, so I believe it will, in fact, do precisely that. And one of the ways that I could see that happening is through robotics. I could see that like robotics just being straight up solved, in that we can have robots that in fact do all tasks, including building more robots, and that seems like the kind of thing that GPT-5 could like almost do, and we would have the prospect that if we train GPT-6, we could have like universal robots that can build more robots and build literally everything.
Speaking of which, did you do any follow-up research on the last discussion where the guest was talking about how Muri couldn't convince economists about AI recursive like economic stuff.
Uh, hmm. No, I didn't look into this. I think that basically,
Yeah.
like I've talked with Robin Hanson on this, and there's been a number of papers by economists, and most of them seem to think of intelligence as just another input that is not fundamentally different um, from basically everything else, and um, this is it feels very much like economics is really the wrong tool for the job. So um, I I don't put very high um, uh, credence um, on the opinions of economists in the same way that I don't put high credence on like people who are really good at playing guitar, because playing guitar is just something really different.
Hmm.
Well, it sounds like it needs a new economics, a
Uh,
new
yeah.
theory, a new economic analysis, like existing microeconomic analysis.
Hmm.
But that's just words.
Yeah. I think definitely. Uh, to a large extent, it is possible to use economic models to model what will happen with advanced AI. It's just that um, probably in the same way as you could, in theory, I don't know. That's a bad analogy. But it just seems like it is uh, really the wrong tool for the job. In the same way that like formal mathematics is wonderful, and there are some really smart formal mathematicians, and formal mathematics is a bad tool for many things in practice. Um, and that's just how life is, right? That all many fields are specialized. Uh, like doctors, for instance, can be extremely highly specialized within their particular fields and have some really strong models within their fields. And once you get like quite a bit away from their area, then if you try to use the models that doctors have built out up painstakingly over hundreds of years, then it just basically fails.
Oh, I think we forgot to pick the discussion topic for next time.
Yeah,